Hey, so Penalized Math and History, and we are going to be rationalizing the radicals. So, if you ever watched some math videos on YouTube, or if you ever watched some videos on radicals before, or these crazy YouTubers that have these kind of videos, like, why do we rationalize whatever this is called, this radical? The question is, why do we rationalize it? Well, before calculators were invented, back in like the 1900s, the USA, Belgium, and some other countries wanted to make math a little bit more easier because it's very hard to actually divide with a calculator and in your head right now to divide by a radical. So the two countries wanted to do something to make the math a little bit more easier. They wanted to rationalize it. The goal for rationalizing is trying to get a number on the bottom as a denominator and anything on the top. It could be a number, a radical, or both. What we care about is having a number on the bottom. So, in the first place, how do we do this? Well, a lot of kids in my math class have been trying to figure out how we can rationalize them, and how the main goal of the game is to get a normal number as a denominator, not a radical. One of them said, why can't we just move this to the top and this to the bottom? So now we have the square root of 2 with the exponent of negative 1 over 1. Well, this is what you wouldn't call a mission success, because even though we have a denominator on the bottom, we still have another math rule that we have broken. And that means having a negative exponent in a number, which we don't want. So, with trying this out, nice try. But let's try another scenario. Well, another one of my classmates is, what happens if we have the same idea, but we have to multiply by 1 over 1? Well, 1 times 1 equals 1, and 1 times the square root of 2 is the square root of 2. So that won't happen either. You know what the actual process is? How we can complete the puzzle? Well, what we can do is, what happens when we multiply this by the square root of 2 and that by the square root of 2? Well, when we do that, we can immediately get rid of the square root of 2. The square root of 2 times the square root of 2 is going to become 2, because they cancel out. And 1 times the square root of 2 is just the square root of 2. And guess what we just did? We just rationalized the radical. And we gained, and we have mission accomplished. Because we have something else besides a radical in the denominator and any kind of number in the numerator. Let's see an example where we would want to rationalize a gigantic radical. Okay, so we have the square root of 3 and the square root of 5. In order to rationalize it, we just want a normal number on the denominator. So we follow the same rule again. Multiply everything by the square root of 5. Okay, so that's going to become 5 as a denominator. And we're also going to have the square root of 15 on the top. And there we go. Here's another one that was rationalized. Let's look at one more example, just in case you have two different numbers in front of the radicals. Okay, so here's an example where we have multiplies in front of the radicals. So what we want to do is have the main goal. Have the denominator as a whole number, and the top number, or the numerator, something else, or both. What really cares is the denominator. So why don't we multiply everything by the square root of 6? When you do that, you get 4 multiplied up by 6, since 6 and 6, the two square roots, become 6's. And we have 3 to the square root of 18. 4 times 6 is going to be 24. But 18 is not a simplified radical. What we can do is pull out two numbers, 9 and 2. The square root of 9 and the square root of 2 equals the square root of 18. Since 9 is a perfect square, we can take that out and turn it into a 3. So now, 3 times 3, because when you put a perfect square into a normal number, you must multiply it with the multiplier. 3 times 3 is 9. And the leftover, which you never use, the square root of 2. And bingo! This is a rationalized radical. We have 9 times the square root of 2, divide that by 24. So not only you get to rationalize the radicals, but you also get to simplify them so many people around the world can understand how you can calculate them and you can do the math. I hope this video has helped you. Thank you for watching Top Analyze the Math Industry. Like and subscribe.